Hey everyone, can you all hear me? All right, I hope you're having a good time at Google I/O. We have a fun presentation for you today. We're going to talk about building data pipelines at Google scale. My name is Michael Manoochehri. I'm a developer programs engineer working primarily with the Google BigQuery team. This talk is very near and dear to my heart. We're going to talk a little bit about building data processing applications using some of Google's cloud services. This is going to be a good talk for people that are already building sort of data processing applications, distributed data applications. And if you're not very familiar with the sort of the big data space, or as we call it at Google, the data space, this will be a good introduction to some of the technologies that we use in general when we're working with this type of this kind of data processing field. So in this talk, I'm going to get started by sort of talking about what a data pipeline is. What do I mean by that? And then I'm going to introduce you to some of the technologies involved with building applications, end-to-end data-intensive applications using Google technologies, including the App Engine Pipeline API and the MapReduce library for App Engine. We'll talk a little bit about the App Engine Datastore and Google BigQuery. I'll show you that. And then we'll talk a little bit about Google Cloud Storage as well. Then we'll dive right into some use cases. I'm going to show you some real use cases that we've developed working with some customers, some common use cases for building data applications on App Engine. And finally, best practices. I'll talk a little bit about performance, and then we'll have time for Q&A. So let's get started. Let me sort of set the stage, and we'll get started with some data application patterns, right? So this is a use case we know very well on the BigQuery team, working with Claritix, who I think are in our sandbox right now, a social game analytics company. So mobile games and social games generate a lot of data. Web applications generate a lot of data as well. You have many clients. Sometimes you have millions of clients if a game goes viral or a mobile application goes viral, generating data, playing games, leveling up, buying new items, sending data back to a web application backend that you've developed, and you're sometimes sending data back to the client itself, right? And so in these situations, you're generating a lot of data, and it can grow immensely. A lot of these applications also need a place to store that data, right, and analyze that data and visualize that data. Think of a check-in application, right? Some kind of application where you're going somewhere, geolocate yourself, maybe at a business, and you check in, and that sends some data to a web backend. And then your application also needs to make some sense of this large amount of data. Let's say you have millions of users checking in all the time, 5 times a day. You're going to want to visualize that data. You're going to want to analyze that data. And it is an immense amount of data. You could be generating gigabytes of data every single day, right? So the sort of two faces of this application require different optimizations, right? So your client-facing web application stack needs to be built for high availability and performance, right? You need to support millions of users making dozens of check-ins a day or playing millions of levels of your game a day, and that's going to generate a lot of hits on your stack. And you're also going to want to push some data back to them. And then on your back end, you're going to want to store a lot of data, ask questions about this data, run aggregate queries over the data, right? So there's different optimizations for different part of these applications. Here's another application pattern that you see a lot in this space. It's moving from unstructured to structured data, or data that's structured in some way, and you need to put it into another format to do something with, to do some work with. The canonical example is web indexing, right? So, HTML originally a presentation layer, millions, billions, trillions, gazillions of web pages on the internet. Google crawls it every day and creates an index of that, so you can actually search for things. Other examples might be, creating n-grams, doing word counts, doing lexical analysis of millions of things. So you're taking data that's structured in some way or unstructured, and you're doing something with it and turning it into structured data, right? So these are examples of data pipelines. In some cases, you can use the same sort of software for the same thing. But let's take a closer look. When your data is small, when you just have 1 record, 1,000 records, 1,000,000 records, you can work with this data on a local machine, right? This is the kind of, when your data is small enough, you can work with your data on your local machine, develop locally, and then send your software to a web application stack, and it'll scale well. You can do queries using the same software backend. You can collect data using the same backend. But as your data gets large, it creates challenges, right? So what are some scale problems, right? When data sizes are small, yeah, you can use MySQL for everything, right? But when it gets large, you have to worry about the amount of data you have overwhelming the memory that you have available or the storage you have available. You get into performance problems, right? So sometimes you have millions of people using your web application, and It doesn't scale. You need to shard your database. You need to have a distributed system to make sure that this works for you. And what about asking questions about your data? When you're using a traditional relational database and you need to run aggregate queries, when you get into the hundreds of millions of rows, the gigabytes and the terabytes, sometimes it's impossible to run such queries, right? So basically what I'm saying is when you have massive data sets, you need to find the right optimal technology for the task. For example, for high availability and performance, you might want to use what we call a NoSQL database, right? Maybe a document data store or a key value data store, something that scales well and is great on distributed architecture. And for analysis tools, you might need an analysis tool that's optimized for aggregate queries, right? And that might differ from your NoSQL backend. And finally, you might need ubiquitous storage, right? Something that's great at archiving, scaling, and a place to store transformed data, right? So a place to store that structured data that you just developed. So let me talk to you a little bit before we get into sort of pipelines. And when I talk about pipelines, I'm talking about pipelining the data from paradigm to paradigm as necessary while you're scaling. But let's introduce you to some of Google's cloud services. I just described a NoSQL data store. We have the App Engine Datastore. And hopefully some of you earlier were in a talk called SQL versus NoSQL, where we talked a little bit about this. But basically, this is a key value data store. It's highly available. It's very high performance. It allows for updating records, creating records, deleting records, and it's got a fluid schema. It's very easy to work with. It's built for web scale applications. And it's built on a technology we use internally at Google called Bigtable. In fact, the whole point of the Google's cloud services is to expose our infrastructure to you developers to use for your own planetary or web scale applications. Like I said, for more information about that, I'm not going to dive too deeply into Datastore, but definitely check out the video for SQL versus NoSQL. I'm sure they figured out which one is best and finally settled the score. Maybe next year we'll do a VI versus Emacs and finally settle that score as well. OK, so Google BigQuery. This is the project that I'm currently working on. Google BigQuery is also an externalization of an internal software that we use called Dremel. And there's also a research paper, just like Bigtable, a research paper about Dremel. You can read about that. So this allows you to write SQL-like queries to analyze massive structured, semi-structured data sets, right? It uses a RESTful API. It's an append-only data store. And it uses, unlike the App Engine data store, it uses a fixed schema. So you can already see that there's a difference between these two data stores. This is optimized for asking questions about your data, whereas data store is optimized for collecting and updating records, right? So if you want to use these together, there is a difference there. It's the schema difference, right? Another one is that data ingestion into BigQuery requires a CSV format. You have to stage your data, CSV format, that's fine. So when we're building pipelines to work with both of these technologies, we're going to need to convert data store data first to CSV before we use it with BigQuery. And if you've never seen BigQuery before, this might be the first talk at I/O where we're talking about BigQuery. Let me just show you a quick example. So we have some public data samples in BigQuery. We have the Wikipedia revision history. You might have seen this already if you've seen us talk about this. Wikipedia revision history up until 2010. We're going to update that with some newer data. So this is something like, I think it's like 300 million records, right? So kind of a small data set, right? So you can run things like, just to give you an example of what you can run, you can ask questions like, what are the top five articles based on revision count? So you probably may have seen this already. So we're querying over millions and millions of records, hundreds of millions of records in just a few seconds. Hang on one second. Oh, there we go. So it took 12 seconds, but we just processed 9 gigabytes of data, hundreds of millions of records. And you can see George W. Bush is the most revised Wikipedia article, followed by WWE wrestling, et cetera, et cetera. And Michael Jackson rounds out the top 5. All right, so that's just an example of how fast BigQuery is to ask questions on aggregate data sets. I'm not going to talk too much more about it. We also have a couple demos. I'm not going to show you this demo. You can see it in another session. But ClickView is a visualization partner, and they're actually building dashboards with BigQuery, allowing you to run real-time analysis on massive data sets. In this case, the American birth statistics since something like 1975. And you can actually do live queries on this. And we'll show you this in another session. And let's see. This session will be called Crunching Big Data with BigQuery. Definitely check it out. It's going to be really fun. I've seen the slides, and it's going to be great. My buddies Ryan and Jordan from the BigQuery team will be talking a little bit more about that. OK, and finally, Google Cloud Storage. So Google Cloud Storage allows you to store whatever you want, unstructured data, binary objects, huge files in the cloud. integrates well with Google App Engine. So this is where we're going to stage our large CSV files before ingestion into BigQuery. So when we actually build our end-to-end applications. It's great, it's very performant, and it's easy to use. Okay, so you remember before I talked about the different paradigms, the different kinds of technology that are optimized for different aspects here. So basically, for me, data pipeline means that what we want to do is move data from paradigm to paradigm to paradigm, right? We want to use App Engine Datastore to collect and serve our web application, to collect data, get back to the client machine. We want to use Google Cloud Storage to store our archive data, our raw data, the structured transformations from the data store, and then Google BigQuery to do the analysis, right? So to me, a pipeline provides a framework for automating these data transfers. And luckily, we have a great library for App Engine called the App Engine Pipeline API. So this allows you to automate workflows, right? So it's built on top of App Engine task queues. And it abstracts away a lot of the complexity of building applications that take data from one place, do something with it, and move it somewhere else. So let's give a quick example. This is the very simplest example of using the Google Pipeline API written in Python. It's the example we have on our website. It's called the add-one class, right? So in this case, what we're going to do is we're going to extend the Pipeline API class, and we're going to write a function that just adds, increments an integer. And then the way we use this is we create a pipeline object, and we just call the start method. This will start up a task that will run this pipeline and return a pipeline ID. And we can refer to that ID and see if the pipeline has completed its task, which in this case is incrementing a number. It's pretty simple. This is as simple as you can go. And then once we're going to check that pipeline and see if it's done. And if it's done, we're going to print out the value, right? So it's basically, if it's finalized, print out the value. So you can see let me go back, just a few lines of code, we've actually created a sort of an asynchronous data pipeline where all we need to do is feed it a number, and it will give us a result based on the transformation that we're employing, which is just increment. The other cool thing about the Pipeline API is you can connect two pipelines together. You can take the output from one and pipe that into another pipeline. So in this case, I've actually taken that add-one pipeline, and I'm piping the result from the first pipeline into another add-one pipeline. So basically, it's add-two, right? So I take the first step, I get a result, and then once the result is done, I yield that, I generate the value, and I put it into the pipeline again. So here's an example. This is actually the code that I just showed you. I added a little Ajax query so you can just see it working. It's pretty trivial. Let's see. Somebody pick a number. I heard you say 42. Great. Let's see if the demo gods are favoring me today. Oh, 43. OK, right. So what this is doing is it's just calling that code I just showed you. It's just taking this number. It's sending it to an App Engine. This is actually an App Engine application running live. Sending it to an App Engine application, starting the pipeline, checking every second to see if it's done. When it's done, return the number. And of course, we have add2. So you can add 2 to the number 1, 2, 3. And there you go. So this is an example of the code I just showed you running live. The other cool thing about the Pipeline API is you can just start up pipelines asynchronously. I could run 2 at once, right? So I can say 1 and 5 or 4, and I can run these at the same time. So these can all be running asynchronously. So basically, with just a little bit of code, I've actually created a workflow. I've created a workflow that increments integers. Now, this is probably overkill for incrementing integers. You're using the power of Google's clouds to increment a number. But this sort of illustrates what we can do with this API. OK, so the Pipeline API, a couple more things to say about it is it lets you write these kind of distributed, asynchronous workflows using procedural code. I can literally just say, start here, move the data here, do this, and then the result will be X. It kind of lets you define sources and sinks, and we'll show you a little bit with that later. Where your inputs can be a certain thing. It can be a number. It can be you can get input from the data store. You can get input from files or from the blob store and App Engine. And I'll show you this a little later too. It provides a useful dashboard for viewing your progress because when you kick off a pipeline, it's running on App Engine task queues in the background, right? And so you may not see. It's hard to see what's going on. Of course, you could go to the App Engine control panel and check out that the task queue's there. But this provides you a cool dashboard to sort of see what's going on. So we talked a little bit about the Pipeline API for developing workflows, but what about that whole transformation step? If I have gigabytes of data, how am I going to distribute the transformation across a number of machines to make it go fast, right? And what can I add to this framework? Or let's say map to this framework to reduce the pain of dealing with this. Well, MapReduce, of course, right? So MapReduce is an abstraction. It's a powerful abstraction for dealing with distributed data processing, right? We use it extensively at Google, and it's used all over in open source implementations, built into all kinds of data processing applications. And I'm going to show you sort of the MapReduce 101. But basically, it's a way to take certain kinds of data processing tasks and distribute them to multiple machines, right? To break them down and to run them all in parallel to get them done faster. So the hello world of MapReduce is, I'm sure some of you know this, but in case you're not familiar with it, the hello world of MapReduce is a word count, right? Word count lends itself really well to MapReduce because it's easy to distribute the tasks into individual work units. So you can actually send them off into individual nodes and then aggregate the result later. So of course, the first step of a MapReduce word count is to have a collection of documents. 3 documents is not a lot, but you might be doing this on 300 million documents or the entire web, right? The first step is a map phase. This is a very simplistic view of MapReduce, but really this is all there is to it. The first step is a map phase. We're going to map through each document, and we're going to do an individual word count, right? What we're going to do is we're going to emit a key value pair. The key will be the word, and the value will be the word count of an individual document, right? So we'll send each document through this function to map through it. And then we'll go through a shuffle phase. And this is sort of the magic, computationally intensive part of MapReduce, where we're going to aggregate the results by key, right? So we're going to put all the hellos in one place, and we're going to take all the worlds and put them in another place. And so we're going to sort through the data by key. And finally, we're going to aggregate the result. We're going to go through what we call a reduce phase. And we're going to take all the individual hello, the dictionary that we created with hello and the dictionary we created with world, and we're going to sum up the results and then provide you with, well, here's the final word count. The first step, sometimes we call this the fan out, where we're mapping through and we're fanning this out to multiple machines. And the reduce step, sometimes we call that the fan in. And as you can see here, this really lends itself well to distributed processing, right? Because each individual unit, each individual little box here can be on a separate machine. And when you have hundreds of millions of documents to process, farming this out to many, many nodes really helps, right? Many workers. So that's basically, that's really like, it seems simple, but what's not simple about this is when I kind of hinted with the shuffle sort, what's not simple is coordinating all of these different units, right? Waiting for one process to end, before you get to the next one, keeping track of each of the individual workers. All of this is very complex, and when you're dealing with, a huge distributed network, that's where the kind of MapReduce framework and all of these open source libraries around MapReduce are really solving is this distribution problem. So so as I just said, there's not just Hadoop, but there's actually lots of open source MapReduce implementations out there. Here's another one, the App Engine MapReduce library. So App Engine has a MapReduce library built on top of the Pipelines API, right? That lets you distribute your data processing task across many machines. So it's open source, it's built on top of task queues, and it stores individual data so that every time you do one of these aggregations, there's an individual data processing step. And the result of those steps is stored in Blob Store. And of course, all the workflows are coordinated with the pipeline API. I showed you the add-one pipe, where I'm just taking data from one place and piping it through to another. This really coordinates a lot of activity, right? So you have the shuffle sort and the MapReduce and the reduce and the mapper phase, and these are all being coordinated with the Pipelines API. What's amazing is using the Pipelines API as a framework for the Google App Engine MapReduce, the amount of code you have to write to coordinate these kind of tasks is really, really small. And I'll show you right now what it looks like. So you remember our add-one pipe code where I was just saying, here is an input, do something with it, and then yield a result? An App Engine MapReduce pipeline is built on top of that, and it looks kind of like this. It looks like a lot of code, but actually it's pretty trivial. The first thing you need is just a name of the step. So this is going to be the name of the pipeline step. And in the MapReduce pipeline, we're going to call 2 functions. We're going to call a mapper function and a reducer function. And in this particular implementation, you don't have to worry about your shuffle sort. It'll run the shuffle sort by itself. So the mapper function, for example, the word count, maybe the mapper function is counting each individual word and then yielding that key value pair that I talked about. And then the reduce will take all the intermediate steps and then aggregate them together. The other thing you can define, if you can see it here, is a source, right? So in this case, I'm asking it to pull out data from the data store. And we have a data store input reader. Actually, we have lots of input and output readers. And then I'm saying sync the data into the Google Cloud Storage, which is our file output writer. And that can also write to Blob Store. We have other input output readers. We have readers that can read compressed data out of Blob Store. If those of you who were in the code lab this morning about this, we also have an App Engine logs reader. So there's all kinds of ways you can read data in and out. And then we can send the parameters to the custom map parameter. Maybe there's a particular, for example, I want to tell the data store reader which entity to read out of data store. There might be different things. And for the reducer, I might want to say, or I do need to say, which Google Cloud Storage bucket I want to use. So you can just send those as a as a list to or a dictionary to the mapper functions. And then shards. You can tell this pipeline how many workers to run, right? This is going to be how many tasks get spun up on App Engine. Doesn't necessarily correlate with instances, and I'll talk about that later in the end. And finally, this can be your whole pipeline, and that can run and dump the resulting data into Google Cloud Storage. But you can also pipe this to another pipeline. So I can say, when this is done, then take that result and do something else with it, and do something else with it. I talked to a couple people internally at Google who are using the same process for some ads-related stuff, and they're doing like 4, 5, 6 joins, piping the result here, doing this, doing another MapReduce. It's pretty complex, but it's really easy to define these using this API. So I'm going to show you some real code from some real use cases. But before I go on, I just want to talk about why use Google App Engine when you have all sorts of other choices for data processing tasks. So first and foremost, scaling things can be really time-consuming and difficult, especially if you're moving from that relational database on a web, like a LAMP stack, to something different, because you're moving from software to software. Sometimes you're moving from hosting provider to something else, and you have to learn how to use the new software, optimize it, worry about the pitfalls and tuning. That can be time-consuming and expensive. So no need to buy new hardware infrastructures. A common pattern actually that I've seen working with customers is that they'll have some web application, then they'll put the data internally to some internal data center and then pipe that data somewhere else. And all of those things are time-consuming, and there's lots of places where that can fail, and a lot of places where you need to optimize those kind of pipes. And so doing everything on App Engine really simplifies that. It's easy to kind of predict your cost. I always maintain that when you move from software paradigm to software paradigm, from relational to NoSQL, there's a cost there of unpredictable cost, because you don't know how well the particular software will perform with your use case, or you may not know how best to tune your stack exactly, et cetera. So there are always unpredictable costs when you move from system to system. And finally, App Engine is a great application development framework, right? It's a scalable, web application stack. Like, everything you need to build a web app is there. So if you're like writing a game and you want to collect data for that game, analyze the data, serve it back to your customers, your players, something like that, everything you need is there, right? So you've got the web application stack, you've got the data store, you can do analysis with BigQuery, cloud storage for archiving. We provide a lot of things, and so it's just a great place to write a web scale app. And it really just simplifies development. That's why I like to use it. All right, so let's look at these in practice. I'm going to show you some actual code, some things that we've built just to sort of test out these ideas, and also from working with customers. I'll show you some of the typical use cases. I'll actually show you 2 in particular. So the first one is just a simple data store mapper. Since I'm on the BigQuery team, a lot of my time is spent worrying about how to get large amounts, like gigabytes and terabytes of data, into BigQuery for analysis, right? It's not as simple as it seems. I mean, a lot of people don't have terabytes of data, but a lot of people have a lot of data in data store. And so I get this question all the time, like, how do I take my data and convert it into something that can be used with BigQuery easily? In this case, we're going to convert data store data from the App Engine data store into first a CSV file, and then we're going to ingest that into BigQuery. We're also going to do a really simple transformation. We're going to transform a timestamp. So BigQuery supports 4 data types: integer, floating point, Boolean, and string. It doesn't have a unique date timestamp. So date formats in BigQuery should be converted to Unix epoch timestamps, or instead of integer. But data store data can support different kinds of timestamps and also different data types. So oftentimes we have to convert that data. It's a pretty trivial transformation, but it lends itself great for MapReduce when you're building these kind of applications. So just to simplify, we're going to take data store entities, we're going to transform them, put them into cloud storage, and then pipe them into Google BigQuery at the end. In this case, I wrote a little sample app that uses an App Engine backend to collect Google Plus statuses. I'm actually just collecting the date of it was published, the person who published it, the URL, and like the summary, we call it the title, the summary of the post. So I wrote this little backend. It just collects. I stopped it after it collects. It's running on a cron. Collects, like every 5 minutes, it collects some data from Google Plus. In fact, you can do it yourself with the Google APIs Explorer. I'll show you which API call I used. First, let me authorize myself. Looks good. So I can. This is the an online API. You can use this yourself. Actually, it's on the Google developer site. So I'm going to run a query for any Google Plus post recently that mentioned Google. Hopefully there's one or two. So the JSON response looks kind of like this. Yeah, I'm just collecting the URL and I think the name and the title. So title is like a summary of the post itself. It's not all the text. And I'm taking that every like 5 minutes and I'm dumping it into the data store, right? So I'm kind of creating this sort of cron job streaming thing. You can do this with any data store data, right? Like if you have a mobile application or people are checking in, you can just use App Engine, collect those check-ins, dump them into data store continuously. So that's basically what I'm doing there. So that's piping into data store. And then what I want to do is take all that data store data. I actually didn't collect a lot because I want this demo to run fast enough for this talk. If you've got gigabytes and gigabytes of data, you may take a few minutes to do these kind of MapReduce transformations. But I want to transform that data from data store into cloud storage, into a CSV format. And then once that's done, once that workflow is done, I want to pipe that data into Google BigQuery, right? So that's the end of my data pipeline. For your BI people out there, this is sort of a classic extract, transform, load operation. This is the kind of the business lingo for BI when they talk about taking data from different data silos and then transforming it into something they can work with and then loading it into another application. Because oftentimes the data you collect in a large business is siloed across multiple data stores, right? So this is one way, this is sort of an example of that kind of transformed to this sort of data pipeline paradigm. And we'll talk a little bit about a more complex silo problem in the next example. All right. So here's the code, right? So I created something called an iterator pipeline. It's doing almost exactly what I described before, but there's no reduce phase, right? I'm just mapping through every single data store data entity. I'm doing a simple transformation on that record, and I'm just dumping it into a large file in Google Cloud Storage. So I've defined a iterator, a map. This is actually the mapper pipeline. It's another one of the pipelines in the MapReduce library. It doesn't have a reduce phase, so it's slightly simpler. And I'm telling it to put the data into a Google Storage bucket that I control. I'm saying output sharding none. That just means it's going to make one big file. You can say one big file or one file per worker if you want to do that. And then at the end, I'm saying yield the result to this other pipeline that I created called Google Cloud Storage to BigQuery. And here's the transformation I'm trying to do. That's the timestamp format that comes out of Google+. It's like a UTC timestamp. I want to transform it into a Unix epoch timestamp, which looks like that. It's just a big integer. And so I'm incorporating like a super simple transformation. So every record, I'm looking for that timestamp, and I'm just converting it. And that's it. And here's the cloud storage to BigQuery handler. So this is just, I'm sorry, pipeline. So this is just another pipeline. Once all of that stuff is done, and the file has been created, the CSV file, I'm going to kick off this new pipeline. So this is what's great about the pipelines API is it lets you finish your job before kicking off another one. So once everything is done, all the data has been mapped out of data store and saved in the files API, I'm going to kick off this ingestion job into BigQuery. So here's an example. This is actual data from the data store. Hopefully it's large enough for you to read. I just pulled out some random ones to display here in this App Engine app. You can see the data format. Late Show with Craig Ferguson, something about Morgan Freeman. The Lotus F1 team has something to say. So this is just random data I collected from Google+. So let's see if this will work. I'm also going to open up my Google Cloud Storage bucket. So this is the bucket where I'm going to dump the data. So right now it's empty. Let me just make sure it's still empty. OK. So let's kick this pipeline off. We're going to move some data. Here is the dashboard that I talked about, right? Looks complex. Don't worry about all the details. I'm just going to show you kind of what it's doing. So this is going to start the pipeline. And just like my little simple pipeline example where it had the little spinner and it was checking to see, this is doing kind of the same thing but on a larger scale. It's showing me which phase of the pipeline it's on right now. And it's refreshing like every 10 seconds or something. Let me auto-refresh it. OK, so now the entire pipeline is done. I only had a few thousand entities in there, I think. So basically, it went through each pipeline, my iterator. It mapped through the data, and then it piped the result into Google Cloud Storage to BigQuery, right? So that's pretty much it. You can inspect each individual thing. I think I had 16 shards for this function. It shows you how much data each shard processed. So they're not equivalent because it was just grabbing data out of the data store. And how long it took. It took whatever 13 seconds to run that. And then I can look here, and this is the object in cloud storage that it's working on to pipe into BigQuery. So let's go back to cloud storage and see if this is complete. Let me refresh. So there it is. Let me grab that real fast. And you can just take a look at it. Let's open it with VI. So can you see that? So as you can see, it's just the same data, but it's now a CSV format, and I've converted all the timestamps to Unix, epoch. OK, great. So that looks good. The BigQuery ingestion step takes a minute or two because we stage the data in Google Cloud Storage, and we tell BigQuery to grab it, and it batches it and ingests it into a format we can do queries on. That might take a minute. I'm not going to wait for that step if it's still running. But OK, it looks like, let me just refresh this real fast. But I did this yesterday just to have, oh, there, it's already done. So this is actually done. I think it's this one. So here it is. So it's actually ingested all those entities. There were only a few thousand, but it's ingested all those entities into BigQuery. And I can look at it and see the data, and I can run queries. So I can say, like, let's see. I could run a query like, what are the top 5, top 5 people that post, like who are the biggest posters, things like that. Actually, let's just run that real fast. Give me one count. So, and this is called Datastore data. So I'm just writing a quick query. I didn't know what the name of my newly created table was because I named it after the timestamp, the current timestamp. So let's just do like the top top posts where let's say the post contains the word, I don't know, Google. Let's see if there's even any in here. Ignore case. The top, and let's do the name. So the top name. Top 5 name and the count from there. So let's see if that'll work. Oh. I don't know what I did there. Oh, thank you. Good eyes, everyone. All right, there you go. The Hangout Show mentions Google a lot. They probably say, I don't know what the Hangout Show is, but I'm assuming it's some kind of Google Hangout show. And they're probably saying, join our Google Hangout, right? And the Crisis Show on Google Hangout. I don't want to watch that. I don't know what that is. Anyway, so there's an example, right? So I've just built a data pipeline application. Now imagine if I was collecting lots and lots of data. I was collecting all the Google Plus posts from everybody I know, and or collecting data from a game, right? So I could collect lots of data from a game. I'm a developer. My analyst from my company comes up and says, at what level do people drop off and go play another game? And I could pipe that data into BigQuery and tell them. With my application, which is also the backend for my mobile game, right? So you can sort of see how you can use this sort of MapReduce and pipelines libraries to build this. So we had a code lab this morning, actually, that showed you how to do exactly what I did, but with app engine logs. The slides of this presentation will be on the website, so you can actually refer to this later. But the code lab is here, and you can kind of check out how to do it. It's very cool. OK, here's another example. This is a more complex example, right? This is another example everybody asks me about. It's how to join 2 siloed data stores into a single data store or database by a unique key, right? So imagine 2 data store entities, right? So you have an App Engine Datastore entity called products, and this is a list or a catalog of all the products that you're selling. So in this case, I have an example of self-driving glasses. I don't know why I wrote that. Self-driving glasses manufactured by Google, and it has unique ID 3, right? So this is your product, your database of like the warehouse or what your description of what you're selling. And for sales, you've got every time one of these products is sold, you also have that unique ID. You have the store that it's sold at, and you have the date and a bunch of other information, of course. But oftentimes these are in different places, and you want to put them in one place. BigQuery is really great at analyzing data that's in a single denormalized database, right? So this is kind of a normalized database where you might have one thing per record. In BigQuery, you can have a sparse database with redundant values and nulls, and it works really well on single table data where you don't have to run a join. So what I'm going to do is I'm going to take this data, I'm going to join it on that key, which is the SKU. It's the product identification number. I'm going to take all that data and join it together, and then I'm going to write it out to a file that BigQuery can use. This is one example where the workflow diagram is more complicated than the actual code. So I'll show you the workflow diagram. This is a lot like the MapReduce sample I showed you before. So the first step I'm going to do is map through each of these separately. I'm going to create 2 mapper pipelines that are separate. And the first mapper pipeline is going to go through the data store entities, and it's going to pull out a key and a value. And the key will be that product identification. And the value is going to be all the other data. I'm just going to treat it as a big string. I'm going to write it out as a big CSV string. And I'm going to do that with the sales database as well. So I'll have 2 different aggregate mappers. But the thing that's similar between them is the key. There'll be a unique key for each one, right? And I'm going to take that. I'm going to do this big shuffle sort, and I'm going to aggregate them by key. So I'm going to take all the ID 1s, and I'm going to put them in one place, ID 2s, and put them in one place, and ID 3s. And this is another example of great for distributed processing, right? So I'm doing these big joins. I'm going to let a different worker work on each of these processes, right? So this is a great way to do distributed work. And then my reduce step. I'm going to take all the aggregates, and I'm going to, for each individual node in this step, for each one of these, I'm going to concatenate them together, right? So I'm going to say for every key 1 product, I'm going to join it together with every other sales example, right? I'm going to dump that into a big CSV file and stick it into BigQuery. It looks very complicated. The code is much simpler than the flowchart. The code looks like this. 2 data store mappers, right? Just like I showed you before. Iterate through the data store. I'm going to call this pipeline join on SKU because that's what I'm doing. I'm going to do something called, with the pipeline, I'm going to use a class called extend or a method called extend. And I'm going to take both mapper outputs, and I'm going to dump them into a new output called all data. It's really simple. So basically, I'm taking 2 data streams, and I'm piping the results together in something I'm calling all data. And then I'm going to send that to the shuffle sort. I'm going to say, shuffle sort, take all of this data and do whatever magic thing that you do with it. Take all the files generated by all data and shuffle them, aggregate them by key. And finally, I'm going to take the result and stick it into a reduce pipeline. And that looks a lot like the other pipelines you've seen before. It's just going to run a reduce function over all that aggregate data and then dump the result into a Google Cloud Storage bucket in CSV format. And then my reduce function looks like, well, I ran out of space, but it can be anything you want. You can actually do a join, but this is also great for like aggregate counts. You want to see for every item what stores sold the most per item. And if you're a huge retailer, or you're a retailer working with like loyalty cards, or even if you're somebody who's a game maker, you can use this kind of processing to do these huge data processing tasks and answer these really difficult questions, right? So you could do a count. I'm going to do a join. You name it, right? So let's look at it now. So this is another example. This is actual data from an App Engine app. I just randomly made stuff up. Here's like Nexus tablet and Android Jelly Beans, and here's the manufacturers. So these are the IDs of the data, right? And here are where they were sold, right? So item number 1, the Galaxy Nexus, was sold at the web store, and item number 4, YouTube T-shirt, was sold at the New York store, right? Similar data connected by ID, but in different data stores. Okay, so let's run this pipeline and see what it looks like. Demo gods? Yes, there we go. So it looks a little more complicated than the one before, right? The one before, we really had just 2 steps. It was like map and then dump it into. This one is running two data store mappers at the same time. Let me refresh this manually. So it's already finished the one. There's not a lot of data in this App Engine app. But basically, it's running both, and it's coordinating the streams into a single shuffle step, right? So you don't have to do that. All the code that I showed you was really the entire code for this application, besides the little, like the Chrome that actually holds the application together. That's all you need to write. And the pipelines API and the MapReduce library take care of all the rest, right? So it's already done with it just mapped through the data store. It's sent both of those streams. It's extending them to the shuffle sort. It's running that now. This might take about a minute, but once it's done with the shuffle service, it's going to kick off the reduce step all by itself. And hopefully at the end of this, we'll have a new CSV file in Google Cloud Storage. And while this is running, I'm just going to say, I've kicked off all of these MapReduce jobs by clicking on a button, which is a valid way to do things. You can also automate this stuff, of course, right? You could run a cron job that kicks off a nightly MapReduce pipeline and does all these things automatically, and that's probably what a lot of people would do when they use this. The other thing you can do is you can stop these in the middle or emit messages during the pipeline, right? Like when one pipeline is complete, you can send an email out. You could update the web app. There's all kinds of ways you can use these to have a better user experience for people who are interacting with these things through the app. So, well, this is going to run for a while. I don't want to take up too much time. We can actually come back to this in just a second. Let's go to the next slide, and I'll pop back over here and see how the MapReduce is going. It's going to take another minute. OK, so performances and best practices. Here's what you can adjust. I already talked about the shards per job, right? So shards just corresponds to tasks or workers. It does not necessarily correspond to instances. So on App Engine, App Engine scales for you. And it'll choose the amount of what we call front-end instances. Those are like basically, it's sort of like analogous to a node or a computer running on a distributed network to fulfill that job. So when you kick off a task, it may spin up several instances with many tasks running on each instance. Or if your job is computationally intensive, it might actually spin up more instances to handle it. But that's the thing you adjust, and I think it's best to try to use as few as possible for the data you're using. But if you spin up many tasks, like for example, say I want to run this process with 15 shards or 20 shards, it's going to take longer than running a distributed process with like 500 shards, right? So you can actually control that. You can also control that to kind of stay under a quota if you're trying to do a daily quota, and you don't want to burst and do 6 million data store reads per hour or whatever. You can adjust that. You can also adjust instance size. You probably don't have to do this much, but occasionally you'll run into a computational task that uses up like all the memory on a front-end instance, and you might need to bump up to a higher instance. You shouldn't have to worry about that too much. If you're doing document processing, like large documents, that may happen. And then task queue settings. Since this is all based on task queues, you can tweak the task queues somewhat. Say, I want to have more task queues running at a particular time, or just the refresh rate or what have you. OK, let's go back to this and see if it's still running. OK, it's done. So this thing is done. It took about you don't see where it's done. It took about a minute, 2 minutes. Let's go to Google Cloud Storage, see if there's a new file. OK, there is. Let me grab that. And let me open this one up. So there it is. Yeah, there wasn't much data in there to begin with, but yeah. So we've taken all that data from different data stores and we've munged it together into CSV. I didn't add the cloud storage to BigQuery pipe, but it's trivial to add that. I can just pipe this data into BigQuery very simply. So that is an example of the join. All right. OK, one more thing to talk about. We have something internally called experimental, for you developers to use, experimental high-performance shuffle. We call it the BigShuffle. When your data gets really large, like gigabytes and gigabytes worth of records, I told you about the shuffle sort. It's computationally intensive, right? So a BigShuffle is a way to use our shuffle infrastructure to run these big shuffle sorts. Normally, all of this stuff is in user space or App Engine space. But sometimes you need more power to do these massive shuffle sorts where all of those aggregates are being built and all those sorting is happening for your MapReduce job. So anyway, we're currently accepting a limited amount of BigShuffle testers. I'll update these slides if you're interested, or you can just come to me and talk to me about how to become one of these trusted testers. But I'll put a link for you to fill out your information on this slide on the Google I/O website. So you can actually try it out. If you've got a lot of data, we'd love to talk to you. And we'd love you to try out this shuffle service and build a pipeline that takes advantage of our infrastructure. Whoops, let me go back. So let me just wrap up. I stole this from another talk, from Jordan's talk, who's sitting right here. But build so that your computation is close to where your data lives, right? I think this is a good adage. This really helps you build these end-to-end pipelines and make them efficient, right? When you're dealing with data that's, it's all in the web, it's all in the same place, it's all being computed on by a single software entity. Worry about your app and not your infrastructure. You guys are software developers. Some of you may be hardware developers or building clusters, but if you're a software developer building a web app, building a game, building a mobile device, a backend for your Android app, you want to worry about the app. You don't want to worry about all this infrastructure. So these libraries and all of this technology that we're offering for you is to help you build this stuff. And finally, the code is so simple. Like, keep it simple, keep it easy to maintain and easy to test. So that's what we're going for here, is to help you do that. So I'll leave you with that. And if you guys have any questions, now's the time. Thank you very much. Cool. So remind me, do people come up to the mic for questions?
Yes, they do.
All right. So there's a microphone set up if you have any questions.
If you have a large process running, let's say in the pipeline you've got like 5 steps, okay? And let's say the first 2 steps use a lot of computational resources. At the 3rd step, you have a failure.
Yeah.
Okay? How do you restart your pipeline from the 3rd step so you're not redoing those first 2 steps?
Right, so there's different ways you can do that. One way is, I've actually been playing with this. One way is that you can you store the aggregate steps in the blob store or in Google Cloud Storage. You can actually do that. So I would recommend, if you're running a huge task, to not delete some of those intermediate steps. The MapReduce pipeline actually has a cleanup phase, but you don't have to run that. You can actually run this and then save the aggregate steps in. I would use Google Cloud Storage for that.
But but the pipeline itself doesn't have any type of mechanism to restart from a different step and say, like, so you see the failure at step 3 and you come in the next day, let's say, you resolve that and it doesn't have a way to restart.
It depends on what the failure is, right? Like, so if failures are network failures or something that's recoverable, it will actually try to recover itself. It won't abort the process completely. If it's something like the data itself is in a format that the next step can't use, or you've done something completely wrong, then we don't have a mechanism to restart that way. Thank you very much for coming to this talk, and catch me afterwards if you have more questions.